What's next? The in condition. What in is used for is assessing whether whatever is on the left side is in as a set comparison condition. Generally, in is used to check against fixed literal values. You can use in to check against a subquery, as in selecting data from a table, but that can be inefficient if the number of rows retrieved from the subquery is a large number of rows or the data is not static. Let's take a look at in. What do we have here? I'm going to select everything from the ACT table, just looking at the ACT ID, where the ACT ID is in 1, 2, 3, 4, 5. And we can see that it's selected ACT IDs 1 to 5. Let's do the example the opposite way around and find everything that is not in that set. We find 48 rows, which is the total 53 less 48, minus the first 5 rows, which we found the first time. Exists. Initially, I set exists to say that it was expression, exists, expression. This was to avoid a certain amount of confusion. And also note that a subquery cannot appear on the left. Now, exists is not quite that simple. What exists actually looks like syntactically is this. There is no expression or any kind of thing on the left of an exists conditional comparison. Let's look at some examples to explain this more clearly. All it's saying is that something where exists or not exists, subquery, expression, etc. And it should be noted that this expression on the right has to contain a subquery. So the exact syntax for exists actually looks like this. Let's look at some examples using exists. What we're doing here is we're finding the ACT ID from the ACT table where it exists in this subquery. That's everything, because this always exists. It's always equal to x, but since it is not a null or a false value, it exists, period. Let's take a look at the second example. Here I'm actually using a subquery. What I'm doing here is I'm going to take everything in the ACT table where it exists in the subquery. Now, we haven't got to subqueries yet, so we don't want to go too far with this. But what we're doing is we're selecting again the ACT ID from the same table, and we're saying where the ACT ID is less than 10 and the ACT ID is equal to the ACT ID in the calling query. So we're actually joining it with a subquery. All we're going to get here is go and find everything in the ACT table where it exists in the subquery. The subquery is actually ACT IDs 1 to 10. So it's taking the ACT IDs in this query and it's saying it exists in that subquery which contains 1 to 10, and thus, well, it's actually 1 to 9 because it's less than 10, so therefore it's 1 to 10. Let's take an example of another exists query. And here we're actually going to go and look in a separate table. What we find here is ACT IDs 2 and 3. Why? Because this subquery finds all the supporting ACT IDs. Supporting ACT IDs distinct values are only 2 or 3. So if we were to execute this and say distinct, remember distinct finds unique values, and I'm simply going to copy and paste this, I find 2 or 3. The point to note is that I've run a subquery and found 2 values, 2 and 3. I then used the where clause in the subquery to link to the calling query alias ACT ID. This is a complicated type of subquery called a correlated subquery. I don't really want to go too far with this at this point in time because that's dealt with later. This is what we're trying to look at, is basically the exists condition. All I'm really trying to get across is that one says where exists and then in a subquery. The next one is expression between expression and expression. This one is very easy. It's just a range check. So I'm just going to take an example and paste it in, and we get 1 to 10. We could do the same thing by doing something like this. It will have the same effect using greater than or equals and less than or equals. And we get on to any sum and all, which are effectively grouping expressions, and we won't cover those now.